So I have here the Fusion 360 model for the main gear of the P39. And what I'm going to talk about making today are these guide frames that are for the actuators that actually actuate the main gear. We are using metric measurements for this project, but because we're in the United States, much of the materials that we have available to us are in imperial measurements. And although this design wasn't really made based upon any particular materials that we have, we are going to end up using the materials that we have, and we've got to adapt the materials to the design now that it's time to manufacture it. The part that I'm going to be making here today, I call the guide frame, and I have it highlighted here. Its thickness in the design, as you can see, is 3 millimeters. And if we look at it from the front here, we'll clear our selection and then set the base of our measurements here, and the maximum measurement is almost 41 millimeters. What we have available to us to make this is a piece of 1.5 by 1.5 by 1/8 inch aluminum angle, which is made of 6061. The way that I do this is I go to the component within my design. So I'll pick this particular component right here. And the best way in Fusion, the best way to pick something where you make sure you have the whole component is to choose its component name over here in the list. And that way you get all of it. And typically what I do at this point is I simply right click on this and hit copy. Now, once I've hit copy, I can go ahead and hit the little plus up here, and that will start me a new design. And at that point, all I have to do is right click in the middle of the design and come down to the word paste new. And that allows me to get an entirely new copy of this particular part placed within this design, which is yet untitled. So I can do that. It's probably easier right now to adjust it a little bit to get it in the right orientation for the machine. So then we have to go ahead and rename it, which I've done up here. I just said save, and I renamed it as the P39 main gear guide frame. Now I've got to remember that since I'm going to use this drawing as the basis for generating the G-code that will actually cut the part out on the milling machine, I have to make sure that the orientation of the part is the same orientation as it will be on the milling machine. Now, if you imagine that you're looking down on the milling machine table, the red axis here, the x-axis, is the horizontal axis. This green axis, which is the axis perpendicular to it. And then there's a vertical axis that goes up and down with the milling head, and that's called the z-axis. Now, what I have to do is make sure that this part is in the same position that I would have it in the milling machine. And quite frankly, I need to be able to deal with the fact that I'm going to be making this thing out of a piece of aluminum angle, which is 1.5 by 1.5 by about 3.5 millimeters. Now, if I leave the part just sitting on the milling machine as you see it, the problem that I'm going to have is that this piece of the angle is actually sticking up, and it is going to very easily interfere with the movement of the tool and the holder above it. So really what I need to do is figure out a way to secure this part in the machine in a way that doesn't have this thing sticking up. And the best way to do that is to use it to hold the thing down. So here's the way I'm going to make it. I have placed this part now on a model of my milling vise, which I got from the company that makes it, which is a company called Kurt to make nice vices. And as you can see, I have placed this so the body, part of the body that I'm going to machine is above the top of the vise, and I'm going to actually place a piece of scrap aluminum in this space right in here so that when the tool penetrates it, it won't hit the vise, it'll simply hit this piece of scrap aluminum. And then I'll bring the other jaw of the vise forward and tighten down on the material. And the nice thing about that is that it makes it very easy and simple for me to take this in and out of my vise, because I can put a stop in here and stop it on some easy to find location on this particular part, and it will just make the machining of it considerably easier. Now do notice that I am going to end up machining the back side of it, so when I pick the contours that I'm going to want to machine on, we have to remember that the part is actually upside down now, and from the way that we had it set on here before. So here we are, and I have set the stock. I created the stock under the setup command here to allow the stock to more or less duplicate the top of this piece of aluminum. And we know we're using an aluminum angle, and we know that this piece of stock actually makes this turn and comes down in the vise. But since the tool is never going to touch it and the vise jaws are going to be closed, it's kind of out of sight, out of mind, and it really doesn't matter that it is not shown in this view. Note here as well that I picked a control point on the stock that's on the material that we're going to cut, and I chose the corner right here because it's easy for me to get to, and that'll line up all the coordinates so that we'll be able to reach all of the places on the top here. So the next step is to determine what milling procedures we're going to use in order to cut out these various different features. The first one we'll notice is that we have several drill holes, so we know that we can use a drilling procedure for that. And then there's this strange looking cam slot and this round pinhole right here. The first one we're going to pick is the drilling, and so we'll pick a drilling process and choose a tool, which in this case is going to be a 3mm tool, which I should have right here. And we'll use flood cooling, and I need to select the whole faces, which Fusion allows me to just tell it that I just want all the same diameter, and then it will choose those for me. I say okay, and then it creates me a drilling procedure that will then generate G-code for the drilling of the holes. The rest of these processes work very much the same way. The next process is going to be an inside contour. We're going to do this cam slot and the pinhole, and to do that I'm going to pick a 2D contour. The tool I'm going to choose here is a 3/16 inch flat end mill, And let me get to the right spot. This one right here, tool number 9, which is a 3/16 inch 3-flute carbide end mill. And I have chosen a 3/16 inch end mill for this because it's a balance of internal strength, which allows me to go fairly fast, and it's still small so that I can get into all these various nooks and crannies. This is only a 1/4 inch hole. If I use, well, it's a little bit bigger than it. Remember, these holes are metric and I'm using imperial size tools, so we have to bear in mind the differences. But nevertheless, the first thing that it expects me to do after I've chosen the tool, I make sure I've chosen flood cooling. Look at these parameters to make sure they're right, and they do look to be right. And then I'll go ahead and choose the geometry. And the geometry is to this bottom contour here. I want the milling tool to enter the top of the face here and cut down to the bottom, and the same thing with this hole. So that's what we want done with this procedure, and I'm going to then make sure that I have the height specified correctly, and I want to go from the stock top to the stock bottom. I want to make sure that we get that cut, and then we may in fact offset about 10 thousandths below the bottom of the flat thing, and so that's about 2/10 of a millimeter down below the bottom. In fact, let's go 1/2 millimeter below the bottom. This flopping back and forth in units is dangerous, and you have to be careful with it. So that is okay. I want to check my passes, and I'm going to use multiple finishing passes here. The reason being that I like to get a second pass. We're going to do this cutting in one pass with this 3/16 inch end mill, but I'm going to follow that with kind of a spring finishing pass, and that should be sufficient to do this. I'll check the rest of the parameters and say okay. So we can see we can see that we did these, but we have a problem here because we didn't do these. I'm going to have a look and see why. The cantilever is not machined because the given lead-in parameters would cause a crash. And so I'll have to go back here and fix that, and I'll do that off camera. Okay, I fixed that little problem off camera. What I did was simply eliminated the lead-in for this hole, and you can see that there's the cut paths right there. Well, let me check the warnings again, and the warnings are just the height of the model, which we know that the height of the model and the height of the stock are not exactly the same. But in this case, we don't really care because the milling machine doesn't care. It will cut it regardless because the difference is only very small. So now we're going to go and pick up the last contour, which is the outsides here. Remember, the stock is actually a piece of angle that is sitting in here. So we are going to have to cut the exterior, but remember that we don't want to cut this part over here because that's in the jaws of the milling vise. So as we pick these contour lines that we're going to cut, we're going to have to watch out for that. We do that by selecting the contours using the Alt key, which allows you to select only a segment of the contour rather than the whole contour. And then you can pick and choose which of the segments that you want to use while you're doing it. So that leaves us a little bit of problem right down in here because there is no contour on either side. So we need to figure out how we're going to get that cut. And the way that we're going to do that is with the lead in, lead out. So first off, I've selected the geometry. I'm going to do the same thing and tell it to cut from the top of the stalk to the bottom of the stalk. And Fusion shows you where the bottom of the tool will come, and that's this blue line right here. And I'm going to check and make sure that it's not actually in conflict with the vise anywhere, which it's not. We're going to do it the same way with a cutting pass and a finishing pass, and then we'll use a lead in for each one of them, and I'm going to make the lead in a horizontal lead in angle of 0. So it'll lead straight in. And I'm going to make the horizontal lead in be a full centimeter. That's the wrong one. This is where that goes. I put it in the wrong box. This is actually the horizontal lead in radius. We can check that now, and it should give us what we want. If it doesn't, we'll go back and change it. So there's the lead in. You can see the machine right here, and the machine shows us that what's going to do, it's going to drop down to here. This is it's penetration. It's not penetrating in this case, but it's actually going to start the cutout here. That's the lead in, which is fine because that's where the piece of aluminum angle is, but it's all above the vise, so it doesn't actually hit the vise, but it does cut cleanly through here. Then when we take this piece of material out of the milling vise, we can just cut that extra material off. Now, the final thing that we have to do is actually go ahead and create the G code. And this particular version of Fusion only allows you to create G code for one of these milling setups at a time, which is fine, actually. It's actually not an advantage to try and automate these processes that we're using when you're doing prototypes like I'm doing here. So it's really no inconvenience at all. So I'm going to go ahead and I'm going to come up here to Actions. I'm going to say, well, really, I should simulate first. I believe I can go ahead and simulate this first thing and we'll see what it looks like. Just to make sure that there's no inconvenient little gotchas that we haven't thought of. And the second one. Here's the second one, which will be the inside contours. Okay, that looks good. And the third one. We'll simulate that. And this should show what I was just talking about, hopefully. It doesn't cut off that top because we decided we didn't need to. But it does all the rest of it, which is what we want. So we can exit the simulation and now go to doing the post-process. So this is called guide plate. I have to make sure I have the right machine here. So the post processor is the Tormac Pass Pilot Post Processor. And that's right, that's correct. It tells me where it's going to put the file when I'm done with it. And I can tell it to go ahead and post. And this operation, so that you understand what I'm doing, it creates the actual G code that will then go to the milling machine. That's the code that actually runs the machine. So it tells me the code was successfully posted. And if I want to view the code, there it is. It pops up here on, I use Code, which is a Microsoft Visual Code to look at G code. I will go ahead now and create the code for all three of these milling procedures. This is the drill here. So I can get rid of that one. This is the one now for the exterior. I'll talk more about the code when we actually cut these things out tomorrow. Okay, that's the finished part. We can remove this from the milling vise and clean it up and deburr it, and it should be ready to go. All right, I'm going to wrap up this recording right here, and we'll continue this project with the milling of the actual part